we're going to solve this cool divisors problem from the Art of Problem Solving. I saw them post it to their Twitter page and thought it was a pretty cool problem. So here's what's going on. We've got this function t, which takes as inputs positive integers. T of n is the number of divisors of n. When we talk about divisors, we're talking about positive integers. So for a couple quick examples of this function, t of 1 is the number of divisors of 1. There's just 1, so t of 1 is equal to 1. T of 2 is the number of divisors of 2. 2 has 2 divisors, 1 and 2. So t of 2 is 2. For another example, t of 4 is equal to 3. 4 has 3 divisors, 1, 2, and 4. So the problem is this. Consider t of x squared plus x plus 1. Is it the case that there are any positive integers x and y so that the number of divisors of x squared plus x plus 1 is y squared plus y plus 1? We want to know if there are any integer solutions to this equation. The solution, I think, is surprisingly simple. Give it a try yourself. My hint for you would be to consider the parity of the things on either side of the equation. Grab a cup of coffee and let's solve this problem before the sun sets and before I get eaten alive by mosquitoes.
Coffee Time Math with your host, Rev of Math.
So like I said, we're going to consider the parity of the stuff on both sides of the equation. Let's start with y squared plus y plus 1, since that doesn't involve our strange function t. Can we make a general claim about the parity of y squared plus y plus 1, the evenness or oddness of it? Well, we're talking about positive integers, so we can just consider things that are even or odd. If y is even, then y squared is even, and then when we add y to that, that will be even, because an even plus an even is even, and then when we add 1 to that, that will be odd. So for even values of y, the right side of the equation is odd. What about for odd values of y? Well, an odd number squared is odd, so y squared would be odd, but when we add an odd number to an odd number, that's an even number. So y squared plus y would be even, but then y squared plus y plus 1 would again be odd. So for every positive integer y, y squared plus y plus 1 is in fact odd. And so, potentially, our solution becomes quite simple. If we can show that the left side of this equation is always even, then we'll be done. We'll have established that there are in fact no integer solutions to this equation. So is t of x squared plus x plus 1 always even? Could it be that simple? Well, again, this function is the number of divisors of the input. So how many divisors does a number have? Well, if the number n is divisible by a, then n must equal a times b for some b. That's the definition of being divisible. That means that divisors come in pairs. For example, 2 is a divisor of 6. 2 times 3 equals 6. So you get those 2 divisors, 2 and 3. So yeah, right? The number of divisors of any number that we input is going to have to be even. Except not necessarily, because there's nothing saying that b can't be equal to a. And in fact, maybe we would have an odd number of divisors. The problem is perfect squares. So if n is a perfect square, then the factors, or the divisors, don't necessarily have to come in distinct pairs. For example, 4 has factors of 1 and 4. Those come in a pair. But 4 is a perfect square. So then we just get one additional factor of 2, which of course gives us an odd value for this t of 4. But if we forget about squares for a moment, for any input that isn't a square, its divisors do come in distinct pairs, and so its number of divisors will be even. So then, before we think too much about squares, maybe x squared plus x plus 1 is never a square. and so we don't have to worry about that. If x squared plus x plus 1 is never a square, well, non-squares always have even numbers of divisors, and so the left side would always be even. So if we can show that x squared plus x plus 1 is never a square, then we're done. I've got a pretty slick argument for you. Check this out. We know that x squared plus x plus 1 is strictly greater than x squared, which is a square. That's fine. Being greater than a square doesn't mean that you can't also be a square. But what's the next square number after x squared? Well, that would be x squared, or excuse me, that would be x plus 1 squared. And this is always less, certainly, than x squared plus 2x plus 1, right? Because these are the same, except this has 2x, this has 1x, and we're considering positive integers. So this is always less than this, but this on the right, you may recognize, is in fact x plus 1 squared, which means x squared plus x plus 1, our input, is strictly between two consecutive squares, which means itself can never be a square. So for all values of x, x squared plus x plus 1 isn't a square, and so its number of divisors, in fact, has to be even. And so what we have on the left side of this equation is always even. Thus, since an even number can never equal an odd number, this equation has no solutions. And that's it.
Consider supporting Wrath of Math on Patreon for exclusive content and to help fuel his addiction to making math videos.